The reduced cost, ease of deployment, and impact that forces even the world's most advanced navies to operate with extreme caution and slowness. Naval mines may sound like something from the past, from the time of World War II, but they remain one of the most efficient weapons ever created in the maritime domain. Some drift just below the surface, connected to the seabed by cables. If a vessel strikes them, detonation occurs immediately. Others remain motionless on the ocean floor, waiting to identify the magnetic signature, vibrations, or engine sound of an approaching ship. When activated, the explosion can rupture the hull below the waterline, precisely the most vulnerable area of any vessel. But before we begin, don't forget to like and subscribe to our channel. Even modern warships can suffer severe damage from just one mine. Therefore, mine warfare has always been a real nightmare for naval commanders. Unlike missiles or aircraft, the threat is often not visible as it approaches. It is already positioned, waiting silently beneath the water. Iran has spent years amassing a vast arsenal of naval mines. Military experts point out that the country can launch them using speedboats, adapted civilian vessels, and submarines. Furthermore, the very geography of the Strait of Hormuz exacerbates the risk. The shipping lanes in the region are about 3 kilometers wide in each direction. Thus, if mines are scattered along these corridors, commercial traffic can be virtually halted in a matter of minutes. This raises a critical question. If this scenario materializes, who will be responsible for clearing the area? For decades, the United States Navy has been preparing specifically for this type of situation. Mine warfare may not have the same visual impact as aircraft carriers or fighter jets, but in practice, it is among the most challenging naval operations that exist. Because the first rule of mine clearance is simple. You need to find them before they find you. And that's not easy when they're hidden underwater, sometimes buried in mud or sand. That's why the Navy uses specialized ships and aircraft designed specifically to locate them. Avenger-class mine countermeasures vessel. These ships look modest when compared to destroyers or cruisers, but they are built very differently. Their hulls are made with materials that reduce the magnetic signature, sometimes even wood coated with fiberglass. This is because many mines are triggered by detecting a ship's magnetic field. Imagine the irony: a modern warship designed to be less detectable than a fishing boat. These ships move slowly through areas suspected of containing mines, scanning the seabed with high-resolution sonar. The sonar creates detailed images of the ocean floor, and operators look for anything out of the ordinary: a circular object, a cable, something that shouldn't be there. When they find something suspicious, the next step begins, and that's when the situation gets really delicate. As soon as a potential mine is identified, the crew typically dispatches a remotely operated vehicle. Think of it as an underwater drone equipped with cameras and lights. One example is a mine-clearing vehicle. It descends slowly through the water towards the target. The operators monitor everything on screens aboard the ship as the camera zooms in. Sometimes it's nothing, just a rock or debris. But on other occasions, it's exactly what they feared: a naval mine lying silently on the seabed. At that moment, the robot positions a small explosive charge next to the mine. Then it retreats and, at a safe distance, the charge is detonated. One less mine, but dozens more may still exist. Ships aren't the only tools used in mine clearance. The Navy also relies heavily on a huge helicopter called the MH-53E Sea Dragon. This machine is gigantic. With a rotor diameter larger than many houses, it can tow specialized equipment through the water. Imagine a helicopter flying low over the sea, while dragging a system more than 90 meters long beneath the surface. These systems can perform various functions. They can search for mines using sonar or by simulating the magnetic and acoustic signature of a large ship. And why do that? Because some mines detonate when they detect these signals. Thus, the helicopter intentionally triggers them from a safe distance. An intense underwater explosion occurs. A column of water rises, and another mine is eliminated. But the helicopter crew needs to fly slowly, low, and steadily over potentially hostile waters. This raises another question. What happens if enemy forces decide to interfere? Removing mines is dangerous enough on its own, but doing so while tensions with Iran are rising adds an extra layer of risk. Iranian naval forces, including units of the Islamic Revolutionary Guard Corps Navy, operate a large number of fast boats in the region. These vessels are designed for swarm tactics. They move quickly, carry rockets, machine guns, and sometimes anti-ship missiles. And in a strait like the Strait of Hormuz, they can appear very quickly. In recent days, the United States has already begun to target the source of the problem: the vessels used to lay the mines. According to the U.S. Central Command, American forces carried out attacks against Iranian naval units operating near the Strait of Hormuz, destroying at least 16 vessels suspected of being used to deploy naval mines. These were not large warships, but smaller vessels capable of quickly entering shipping lanes and laying mines within minutes before disappearing again. American authorities claim that the objective of these attacks is simple: to prevent the mines from even reaching the water. In fact, the campaign has focused heavily on Iran's so-called mine-laying infrastructure, targeting both the vessels and the storage sites where the mines are kept. Not every mine requires the use of robots. Sometimes the simplest method is also the fastest. If a floating mine is spotted on the surface, sailors can simply destroy it using heavy machine guns or automatic cannons mounted on the ship. It's easy to imagine sailors positioned on the deck of a destroyer, firing into the water until a mine is detonated. In other cases, explosive charges are dropped nearby, and in more critical situations, even missiles or small precision weapons may be used when there is an immediate risk to surrounding vessels. It's an intense, noisy, and unsophisticated procedure. But, on a strategic maritime route, acting quickly is crucial. The primary purpose of a mine clearance operation is not to eliminate all mines scattered across the ocean. That would be impractical. Instead, the Navy establishes a safe corridor, a relatively narrow channel, but one sufficient to allow the safe passage of commercial vessels. This route is carefully mapped, continuously monitored, and, once cleared, initiates the next stage: the escort operations. Should tensions escalate further, warships from the United States and allied countries will escort commercial vessels through the Strait of Hormuz. Destroyers lead the convoy, aircraft monitor the airspace, drones track potential threats, while oil tankers advance in formation like a slow and protected convoy. This type of strategy has been adopted in previous periods of crisis in the Persian Gulf, but it is far from being routine, because every crossing of the strait carries the same constant uncertainty. What if another mine appears? What if a smaller vessel approaches too quickly? What if the situation escalates even further?